And thanks for joining me here. Um, and now I'm gonna share my screen and that screen. So hey, from time to time, I will ask someone to unmute their microphone and like call on you basically. So like Zach, you're kind of new to the class. Zach, can you unmute for a second? Can you see okay, so can you see the screen I'm sharing? Right now it would be like well, in a second here once it focuses. My hand and my paper. Can you see that? No, you can't see my hand and my screen? Now you can. So you can see my hand and my paper. Okay. All right. Whoa. You had me worried there for a second, Zach. But okay, Zach, can you? Sorry, still Zach. Can you now? I guess I want to see how quick this is. Can you now see my Google Classroom?
Yeah.
So there's a little bit of a delay.
Yeah, there is.
Okay. Well, hey, let's get rolling here. We only have like about a half an hour. Well, we can go a little bit long if we need to, but I don't think we will. On Monday, Mrs. Milano is having another live session at 11:15. So really quick, still looking for some syllabuses signed, but I don't even know if everyone even saw that. And let me ask you this, Zach, I'm not picking on you, but you said you had some trouble attaching the Thursday step 2. Is that true?
Yeah.
Did anyone else experience trouble? Like you can like unmute or type into the comment section or the chat, whatever it is. Has anyone else experienced a little bit of like trouble attaching work to one of those assignments yesterday? Kind of like Zach. Anybody? Dakaya? Okay. All right. I don't know what the problem is. I feel bad. I kind of feel like an idiot a little bit, but I think what I'm just gonna do in the near future, I'm just gonna make it like a very typical assignment. I might not even include the PDFs for a while, just in case. So I'll just make the assignment and I'll explain, and then you can just attach your own PDF, because kind of like I commented in the stream, you're really just going to ultimately be doing your notes and your homework on the paper copy and then attaching that, like as a pic. Even if it's a picture, I'm okay with that, especially for the time being, okay? And however you do that, then you can do that. A lot of people find it really easy if they have the Google Classroom app on their phone. They can like take the picture directly with the Google Classroom app in that assignment, right in their phone. But for the time being, I'm just going to keep it simple. Like, I'm not even going to worry about me potentially using Kami to like write feedback back to you like on your work. I'm just not even going to worry about that for now. So for the near future, I'm just going to kind of keep it real simple, and hopefully there's no more issues. But I don't know. So maybe I will. So like Dakaya, and it's Dakaya, right? That's how I pronounce it. Maybe I will. Maybe I'll repost that assignment and have you guys try again. So, you know, for the time being, like today your attendance matters, okay? But I'll be pretty lenient on like late work here at first while we kind of work out the kinks of like turning in like a picture or a PDF. I'm not, again, like I might just kind of totally forget about all this, like all these Cami features for now, because I kind of need you guys doing this on paper. It's math class. Um, like I was telling Miss Schultz, you know, like yeah, we really need to do things on paper because it's math, and doing it with Cami is just way too messy. And taking notes, I don't even know how you guys would do that, like clicking back and forth between like my video and your PDF file on Cami. I don't even know how that would work. So let's just stick with doing it on paper and turning in like a picture or a PDF of that paper. So speaking of which, let's take care of some business today. Get out this paper. So there might be a little bit of lag like Zach is experiencing, or maybe it's only Zach. Maybe it's only Zach. But I just put this on my camera. So if you cannot see my camera and, you know, like literally my pen in my hand in the next couple seconds, please unmute and let me know. Okay, but otherwise I'm going to assume that everyone can see my pen doing its thing and stuff. And again, I might be calling on people from time to time, so just be ready to unmute and, you know, answer the question or whatever. But here I go. This is 1.1 notes. You're going to be turning this in, you know, afterwards. Like I got an assignment ready to go. You know, all I really need to do is like upload this video. You know, but I'll be posting this assignment and your homework assignment like pretty much right after this session's done. So take these notes because this is going to be like the first thing you turn in today, okay? Here we go. Jack, do you remember what natural numbers are?
Positive numbers.
That's pretty close. That's, yeah, close enough. Just write this down, everybody. 1, 2, 3, 4, 5, ... And also write this down. A lot of people refer to the natural numbers as the counting numbers because you use these numbers to count. You start with 1, 2, 3, 4, 5, 6, 7, and it literally goes on forever. So those are the natural numbers, and yes, like Jack said, they're all positive. William, do you know what the whole numbers are all about?
Not negative numbers.
That's true. The whole numbers are actually when you now toss in 0. So they're, like William said, they're really nice positive numbers. And just writing this pretty much tells the tale. You know, 0, 1, 2, 3, 4, 5. Okay. Integers. Mackenzie, do you know what the integers are all about? I'm just seeing if anyone else joined in here.
No, I did not.
Does anyone, well, I guess it's not a normal class where I can just say, does anyone know? So now check this out. You might already know this. The integers, you can now include negative numbers. But we're still keeping it like really nice. Okay? So integers, I'm only writing down, and you can only write down this, but technically the integers go off forever in the negatives, like -4, -5, -6, -7, and it just keeps going like that. But it also includes like 4, 5, 6, 7, okay? So these are what are known as like the integers. So for example, you'll notice that there's a lot of repeats, you know? Like the whole numbers, for example, include all the natural numbers, but it also has 0. And then the integers include all of the whole numbers, but now we're kind of tacking on -1, -2, -3, -4, -5, -6, and like forever. Okay? Aaron, do you know anything about rational numbers? Like we're getting a little bit more crazy. But Aaron, do you know anything about rational numbers at all?
Numbers that don't repeat.
Let's see. You're in the right ballpark. You know, you got something good going on there. Technically, in a textbook, rational numbers you can write as a quotient of two integers, which is really just a fancy way of saying, this is unbelievable. 1 second, write that down, Mr. Falk. I have to tell you later. I got a cyber class right now. All right. Okay, so pretty much you can write as a fraction. Oh crap, that actually went here. So you can just do that, or rewrite the word fraction. You know, so in other words, it can be written as a fraction. So are the natural numbers included? Like, for example, the number 3, which is natural, can you also call that rational? Right? Connor, what do you think? Do you think we can say 3 is not only natural, but it's also rational?
Yes.
Yeah. And because you can write it like that. You know, you can write it as 3/1, a fraction. Now, I think it was Aaron, I can't remember for sure if it was Aaron, but whoever said about like how there's no repeats or something, a lot of people remember that rational numbers, let's see here. I'm skipping ahead here, but that's okay. Also included are numbers with terminating or repeating decimals. So if a number has a decimal that just ends at some point, you know, like 4.7, okay, or like 9.15, these decimals end at some point. So like not only could we could write this as a fraction, you know, but a lot of people find it easier to just remember that if the decimal ends at some point, it's rational. Like 3 is technically like 3.0, you know, so it has a decimal that ends. But also repeating decimals, like if it's like, you know, 5.3 repeating, you know, that's actually also rational because the decimal goes on forever, but at least there's like a pattern to it. And another way to remember that is like, you know, 0.3 repeating. Does anyone know what fraction that is? Feel free to just unmute yourself and shout it out. Does anyone know what fraction 0.3 repeating is? Maybe, maybe not. That's actually 1/3. You know, so any fraction is rational. You know what I mean? So in other words, you know, but again, a lot of people remember that it's just like a terminating decimal, or it's a never-ending decimal, but at least it repeats a pattern, okay? Are the whole numbers included in the rational numbers? Yeah, because, you know, 0 can be written as 0/1, or it's a decimal that ends, or whatever. Integers, are the integers also, you can say, are rational? Yeah, because like -5 is an integer, but you can also say it's rational because it's like, you know, -5.0, the decimal just ends, it never really even starts, kinda. But you could also write it as like -5/1. Okay? So I'm going to take a little breath here for a few seconds as you guys like, you know, make sure you get this all written down, and if you guys have a chance or you want to like ask any questions. Are there any questions? Let's see, Mackenzie, William, Zach, Takaya, Aaron, Connor, Jack, and Allison. please speak up now. If there's anyone else in here, like Brianna, for example, or whoever else, we're getting new students all the time, so it's kind of a rough start here. But so Mackenzie, William, Zach, Takaya, Aaron, Connor, Jack, Allison. If there's anyone else in the room, let me know, and just let me know, period, anybody, if you guys have any questions about rational numbers. All right, so likewise, Jack, what about irrational numbers?
They don't have a pattern, or they repeat in the pattern.
Yeah, okay. I like that. So I guess we'll skip down to here. So Jack had a good answer. So moving down to here, decimals, okay, never end and never repeat, like a pattern. That's how a lot of people just remember what irrational is. Like it's irrational. The decimal goes on forever, like randomly. It never even repeats a pattern. Okay? And then another like the I guess the more official definition is that you cannot write it as a fraction of like a quotient of two integers, a fraction that uses integers with the numerator and denominator. But yeah, like Jack's answer is totally fine, right? Let's see here. Zach, do you know of any examples of a number that's actually irrational and it has like a decimal that like goes on literally forever with no pattern to it? Do you know, Zach?
0.5 repeating.
Well, good try, but that would repeat, So it's got to be like a number that its decimal is like just so random, you know what I mean? Does anybody know? You can unmute yourself and shout it out.
Pi.
Nice. Who said that?
Connor.
Connor? Nice, Connor, if I heard that right. Yeah, pi. Think about it. Think about pi's decimal, 3.14159, and that's all I know by heart. But it goes on forever, Other classic examples are a lot of square roots. A lot of square roots, okay? Like square root of 2, square root of 5, you know what I mean? But we might need to kind of pick up the pace here a little bit. But yeah, those numbers are irrational. Here, okay, some of your homework involves, which hopefully we can get to in less than 10 minutes here. Some of your homework is going to ask for like, is something true or false? And if it's false, give like what's called a counter example. So the square of a number is always greater than the number. Is that always true? So like write this down, like 3 squared is going to equal 9. So based on that example, it's true because when you square a number, it becomes greater, right? When you square 3, it gets bigger, right? Can anyone think of an example where, like, if you actually squared a number, I'll give someone a bonus point for this. Can anyone think of like who just unmuted? Anybody? Or someone just joined in?
The square root of 1.
Was this Connor?
Yeah.
All right. Good job, Connor. So 1 squared, I think you meant to say, but I'll give it to you.
Yeah, sorry.
1 squared just stays 1. So that doesn't become greater, that like stays the same. So this answer is actually false because you can come up with what's called a counterexample. Another counterexample is, I guess, see, that one was not, but this one is, what if you squared 0? Heck, what if you squared like 1/4, which is like, you could also write it as like 0.25. If you square a number like this, it actually gets smaller. Isn't that crazy? But anyway, so the bottom line is this is a false statement because you can come up with like a lot of these counterexamples, right? This one's not a counterexample. No fractions are whole numbers. Let me write down Connor's name here. No fractions are whole numbers. That's actually false. Can anyone think of why to yourself? No fractions are actually whole numbers. Because what about like 4/2? 4/2 just becomes 2. So make sure you write that down. The square root of a number is always less than a number. Well, guess what? That's also false, because what if you do the square root of 1? That doesn't get smaller, it just stays the same. Same with the square root of 0. That just stays the same. And you know what? Same with like the square root of, say, 0.04. Like a fraction or like a decimal. This is actually 0.02. So that actually gets bigger, See, this is true most of the time. You take the square root of a number, it gets smaller. Like the square root of 16 just becomes like 4. Okay? Like William, are we all comfortable with square roots? Maybe I should check that. So like William, do you know what the square root of 36 is?
No.
No? Mattis or Mackenzie, do you know the square root of 36?
6.
6, very good. So the square root of a number, right, is like what number times itself would be 36. So you can see like most of the time the square root of something, it gets smaller, but not all the time. So these are good counterexamples. How about the square root of a number? Is it always a crazy... So remember what Jack said. Irrational usually means like a crazy decimal, Like the square root of 2. If you tried that on your calculator, you'd get like 0.14, blah, 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 right? Is a square root always a crazy decimal? Who can I call? Aaron, what do you think? Is a square root, like square root of 2 is crazy, nasty decimal. Square root of 5, is crazy, irrational. But Aaron, is it always that, square root of a number?
No.
Like, can you think of a good counterexample other than this one?
49.
Good one. Square root of 49 is just 7, And 7 is nice and rational. Heck, 7 is like natural. It's natural. It's a whole number. It's definitely not irrational. So good job. Let me know really quick. Does anyone? I'm going to change pages while you guys turn your paper over, basically. Does anyone need more time to write this down? Because you're going to be turning this in a few minutes. 3, 2, 1. All right, let me know. Okay, last page, super quick. And then we'll look at the homework and just make sure there's no, surprises there. Some simple symbols here, what this says, right? Because the alligator mouth wants to eat the larger thing, the larger quantity. This would mean that A would be less than B. Just some quick review. Obviously, that is an equal sign, so A would be equal to B. Here, since the alligator mouth wants to eat the larger thing, that would mean that A would be greater than B. Okay? So, like, I don't know, I just kind of know this, and you might just kind of know this. You know, the fact that if the alligator wants to eat the bigger thing, that just you just know that's a less than. Some people look at that as like, oh, this looks more like an L than that looks like an L, so that's the less, because, you know, L, less than. But I don't know. Like, one way or another, you know, you should kind of know these symbols pretty well. So, I mean, here, check it out. 6/9, Zach. Can we rewrite 6/9 in a little different way?
Yeah.
What is 6/9? Like, what can it reduce to?
2/3.
Yeah, so you know what? Check it out. I guess these two are actually equal. And really quick, just, you know, might as well cut to the chase. Especially with fractions like example A and example D, you can change. So write this down. Change to decimals if you must. Like that's usually a pretty nice strategy, which maybe we'll have to do that with question D. I don't know. But what symbol you think goes here, William? Which one's bigger, 4.022 or 4.03, William?
4.03.
Nice. Couldn't trick you there. So you'd have a less than symbol there. Do negatives screw us up, Connor? Like, what do you think goes here, a less than or a greater than, Connor?
Greater than.
Nice. -9 is smaller. You know, even though 9 is bigger than 7, you know, negatives kind of change that up, you know. So -9 is like more negative, right? You know, if you have like -$7, you actually have more money than if you have -$9. I know that's barely makes sense with money, but all right, so -1/2. Okay, so these are both negative, right? So I mean, is -1/2 more negative? Like, is it a bigger negative? Or is -1/8 a bigger negative, which would make it smaller? This is where you might want to like change. You might want to change. You might need to. Jack, how do we change these to decimals?
I don't know.
You can literally just divide these numbers on your. You could like literally do 1 divided by 2, or I guess like -1 divided by 2, and you would see that's like -0.5 as a decimal. Now this, you know, Dakaya, do you have a calculator handy? Can you do 1 divided by 8 really quick on your calculator? Nice. So with the negative, we got -0.125. So when you compare this decimal and this decimal, it looks like this one is more negative, like it's a bigger negative. So this, you know, this one's bigger because it's like, you know, not as negative. All right. So next definition, two numbers. I know it's already 11:16, but Mrs. Milano, I don't believe, correct me if I'm wrong, I don't think Mrs. Milano is doing a meeting today, but so we'll go a few minutes over here, our planned. Two numbers that are the same distance from 0 on a number line but lie in opposite directions are opposites. So write that down. Okay? Like -3 and positive 3. I mean, a lot of you guys, maybe all of you guys, already know the concept of like two numbers that are opposites of each other. They have the opposite sign. Well, that just means that they're like the same distance from 0 on the number line, you know. This is just like a fancy way to define that, you know, two numbers. Like -7 and +7 are opposites. Do you know what symbol this is, Aaron? So the blank blank of a number is its distance from 0 on a number line. Like essentially, Aaron, do you know what this symbol means?
No.
Mackenzie, do you know?
No, I do not.
Okay. It's absolute. I don't really blame anybody. Don't feel too bad. A lot of people, you know, in like at the algebra 1, like, you know, in algebra 1. So like that's why we're writing it down. You know, that this might be the first time we've ever learned about what's called absolute value. Okay? So the absolute value of a number just means like how far away from 0 is it? But in other words, you do like the absolute value of 5, it's 5. And the absolute value of -5 is also 5. So I guess what I'm getting at is a lot of people, like me included, just look at absolute value and they think to themselves, oh, it's going to make the number positive in, you know, if it's not already positive. You know what I mean? So it makes negative numbers into just positive numbers, and with positive numbers, it just kind of leaves it alone, because again, it's like how far away from 0 on the number line it is. So like you can pretty much just say makes it positive if not already positive. Okay, so write that down really quick. And then, if I may, I'm just going to kind of take a couple minutes just to kind of make sure no one's thrown off by the by what's on your homework, okay, like your assignment. So, does anyone not have that written down? All right. So again, I'm going to post that like as soon as I get the video sort of made, so I can include the video for people that just joined the class. I'll post that assignment like momentarily. It actually might, to upload the video, it might take actually like, you know, 10 minutes or something. But so here's the homework. Let me know if you can't see the homework here, okay? 1 through 10, you know, you're gonna check off every box that you can. Like you don't have to pick just one, you know. Like for example, Aaron, like -1, could you check the natural? Is it natural? Is -1 like a natural counting number?
No.
No. Is it a whole number, Aaron?
Yeah.
No. Remember. Like, so keep your notes handy, everybody. Whole numbers are like the natural numbers, but also 0. So like the whole numbers are 0, 1, 2, 3, 4. You might be thinking of integers. Integers is when you start tossing in like -1, -2, -3, -4, -5, and so on. So it is an integer. Aaron, is it also rational?
Yeah.
Yeah, which means it's not irrational. So for number 1, you would check off integer and rational. So you can check multiple boxes for 1 through 10, okay? Why is it not scrolling? Oh my god. So 19 through 23, this is where you're going to like, you're either just going to say true or you're going to say false, because you can give like a counter example, okay? Let's see here. Zach. I just want to make sure we know what's going on here with... Does everyone know, like Zach, do you know what the word multiple means? Every multiple of 3.
Whatever can be multiplied by 3.
Yeah, like you might have said it a little bit wrong, but I think you know what you're trying to say. So, like, Zach, can you give me a few multiples of 3?
6, 9.
Yeah, there you go. So you got it. So 3, 6, 9, 12, 15, right? Those are all the so it's like, Zach, does everyone know what odd means? You know what odd is, Zach?
Yeah.
Okay, like it's 1, 3, 5. Again, like I'm gonna linger on here. Like if you wanna stay on the meat while you do your homework, I'll stay on as well. But I'm just trying to make sure there's no surprises here for people. So that's what a multiple is. All negative numbers are integers. That's either true or it's false. You know what I mean? And if it's false, let's do number 20 together really quick. How about that? William, are all negative numbers, are they all integers, William?
Yeah.
Yeah, like -1 and but like keep in mind, everybody, couldn't I say like -1.7, you know, like -3.85, you know what I mean? So all negative numbers means like all numbers, like not just all negative integers, you know. So 20 is actually false, because you could say like -5.8, you know, or like whatever decimal you want. You know what I'm saying? Like there's a lot of counter examples to number 20, okay? Negative numbers is, say like there, might take some, again, I'll stay on. These ones I don't think should cause you guys much trouble necessarily. Just, again, change to a decimal if there's any doubt by what? Literally doing 2 divided by 3 or like 1 divided by 6. You know what I'm saying? Ordering them, that's kind of the same thing. You know, change them to decimals if you need to kind of compare them easier. And then like on the absolute value, so like Mackenzie, like what would be like the absolute value of -9, Mackenzie?
9.
Very good, very good. You pick up on it quick. So the answer here is just 9. Dakaya, how about 34? Like what's the absolute value of 4?
I don't know.
It's just 4, you know. So absolute value pretty much like guarantees that it's positive, and 4 is already positive, so like the answer is just 4, like plain old 4. Okay. And then in these last few, you're just going to like write these as a fraction to kind of show that it is actually rational. So let's do a couple together. You know, number 5 is actually pretty easy. Jack, how can you write 5 as like a fraction?
5/10.
Close. You might be thinking of number 42 or something.
5/1 I meant.
Yeah, just 5/1. Okay? But Jack, might as well stay on here, Jack. 0.2, right? As a fraction. Like, how do you like actually say this? Like 2/10, correct?
Yeah.
So yeah, like that's literally the fraction is 2/10. And you can just leave it at that. And you actually have like maybe another option, you know, like number 44 might be a little tricky. A lot of calculators, right? A lot of calculators, you could literally just type in like 0.2, and then there's like a special function, like built-in buttons on your calculator that could just like automatically change it to a fraction for you, okay? So again, like I'll shut up now, and I'll stay on here, and if you want to stay on and do your homework, and if a question comes up, just kind of give me a shout. I'll stay on here for another little while. So again, I'll stay, yeah, I'll stay on, but I'm going to be like uploading the video here. So if you need any help, just kind of give me a shout. But if you want to log off, you can log off and just be ready to turn in your notes momentarily, and then eventually turn in this homework, okay? Just with like a picture, all right? Any quick questions, feel free to ask, but have a good day. If you just want to kind of sign out, I'll see you later.
Mr. Falk,
What's up, Jack?
for the syllabus thingy, every time I go into the Google Forms, it says I turned it in, which I did, but on the classroom it says that it's still assigned to me.
Let's take a look-see. Google Classroom has been, okay. So there you are. Yeah, so when you go in, you've hit like submit. Did they hit
Yeah.
they hit submit at the bottom, and so they can't type in anymore?
I didn't mark it as done, that's why.
So you have to submit, and then you have to mark it as done?
Yeah.
Try that right now, and let's see if it
Can you see the syllabus?
I can go in there and see all the responses, and I'll get like a wait, when did I make this due? I probably made it due, not even due yet. Like maybe I made it due tonight by like
Yeah, do it 8.
okay. So yeah, it just happened. So now you're in the turned in group, and I can go in there and like look at everyone's responses. Yeah, so you're good now with the. That's annoying. Is it? So you hit submit, and then mark as done?
Yeah.
What the heck? How about while I have you quick, getting back to all this other cami nonsense and issues. You turned in your notes, okay. Was there any issues turning in your notes that you had?
No.
Did you just turn in pics, or like you went full PDF?
PDF.
Okay. But you didn't have any actual trouble. Now, how about the repetition thing? So with the repetition thing, like Zach, did you try turning in the repetition assignment yesterday?
I finished it right before this Google Meet started, so I have to turn in still.
Okay. Can you try doing that while you're still in the Google Meet here? Because as you do that, what I did was I created an actual like Kami assignment. There's actually a difference. Like I can create an assignment and I can create like a Kami assignment. So I'm experimenting a little bit, and I made this like a Kami assignment, which I don't know. So like Zach was having a little bit of trouble, and it looks like Dakaya was having some trouble. but
Yeah, I'm taking pictures of it right now.
yeah, and you know what? I don't think this video recorded the class. Oh my gosh. That's awesome. Or is it like still or are we still recording right now? It won't stop.